Okay, let's look at the homework 7, problem number 3, and part A. All right, I'll help you set up the integral. All right, so we're looking at the disk. R is less than or equal to 2a cosine of theta. So first we have to figure out what kind of disk we're looking at. All right, so we have R is less than or equal to 2a cosine of theta. So what we can do is we can multiply through by r. So we have r squared is less than or equal to 2a r cosine theta. All right. Then r squared is simply in Cartesian coordinate system. It's just x squared plus y squared, right? Is less than or equal to 2a is just a constant, 2a, and r cosine theta is x. Right? Then what we can do is subtract 2ax from both sides. So we have x squared minus 2ax, and I'm gonna give a little bit of room here. Y squared is less than or equal to 0. Right? But what we can do is we can add the a squared here so that we can complete the square. So I'm gonna add a squared to both sides. So you have a squared here, and I'm gonna add a square on the other side as well. Alright, so this is gonna give you the equation of an equation of a circle, because here, using these three terms, maybe I should do that here. Using these three terms together, we can create x minus a squared, right, plus y squared is less than or equal to a squared, right? So we can see that this is going to be a disk centered at a comma 0 with radius a, right? So it looks like this, right? So if you sketch the graph, let's see, maybe draw a picture here. Alright, so you have x-axis and y-axis, so that's y-axis, x-axis. Right, here is a. So a comma 0 is the center, so this is going to be the center, and the radius is a, so this is going to be 2a there. Then you have a circle which looks like this. Alright, then we're looking at the centroid of the area, the first quadrant half disk. So we're looking at this guy right here. So it's got to be in the first quadrant. So this is the disk, a half disk we're considering. Alright, so first, in order to find the centroid, let's find the x bar, and I'll let you do the y bar. Alright, so in order to find x bar, we need to be able to know the area. So area of this half disk, right? So we actually know the area by geometry, but set up the integral first, right? So it's going to be an integral. Alright, so area element is going to be r dr, so it's going to be r dr d theta, right? Then here's what it looks like. So we're looking at so for a fixed theta, so say you have for a fixed theta, all right, so all values start from 0 all the way to, so here is 2a cosine of theta. So this is r equals 2a cosine of theta. So it looks like it's going to go from 0 to 2a cosine theta. So 0 to 2a cosine of theta. All right. Then angle wise, angle is going to start from 0, then keep on swiping all these the half disk. Then we have to, angle wise, we have to go to, looks like a pi over 2 to cover the entire half disk. So angle starts from 0, then go up to pi over 2, right? But if you compute this, you realize that I'll skip this since from geometry, area of the half disk is 1/2 pi a squared. So you're gonna get that. All right. Then the next thing is that you need to compute the double integral x dA over the same disk. So let's see. So we can write it as let's see. I'm gonna call this guy. It's a half disk. Let's call this guy S. So let's say over the half disk S. Right. So this is going to be. Right, so you have dA is r dr d theta, x is r cosine of theta. So there's going to be two r's, so r squared cosine of theta dr d theta. Then you have a double integral, right? R goes from again 0 to 2a cosine of theta. Then it goes from 0 to pi over 2. Alright. Then once you found those two, all you have to do to find x bar is that you're going to have to multiply, compute this in double integral. But the x bar can be found by dividing this guy, which is the result of that, by the area A, which is this guy right here. All right, then I'll let you compute that on your own. All right, that's it. I hope that this was clear.